No, I.
Square root.
The square root of negative one.
E. All right. Let's give you some information first. So start with from a long time ago, when the math started. All right, let's hear. What?
I have a late pass.
All right, okay. You okay?
Yeah.
You feeling better today? Okay. All right. So let's start with the imaginary number. Let's just start with where does that come from, right? So for example, a real number is this. So it'd be like a, so first of all, in the history of math, they don't believe in negative number. And I'm going to explain to you why they don't believe in negative number. So for example, if 2x equal to 4, this is x equal to 2. So this is okay. This is a real number. This is a 2. So this is integers, right? Integer and a whole number. And you say, oh, okay, well, that's true. And so, and when the math start evolving, so math usually didn't believe in negative number until the longest time. So do you know who was the first person that thought of negative numbers? Like which part of region that believed it? It's actually not Asia. Asia didn't believe in negative number.
Middle East. Oh.
Huh?
Middle East.
No.
The Middle
Yes.
East is in America.
Huh?
It's not there.
Europe.
No. America back then still in like all the Indians.
Europe.
Not Europe.
Africa.
What's left? Australia.
It's actually the Mayans.
That's the America.
That's a South America.
That's America. They said America.
Did you say Americas? But there's a more like specific is Mayans because back then there was Indians in like America.
Okay,
North
Central
America.
America. Is that specific enough?
No, it's South. Yeah, it's South America. It's the Mayans.
That's Central America, Mr. Yang. Maya is Central America. That's if you want to say it's north of South America.
Okay, I don't know my geography, so
Literally. Oh my God.
No, has to be wrong.
Arthur's not wrong. Arthur knows his geography.
You know, or
okay. So it start with they don't believe in negative number, right? So it doesn't make sense because let's just say if I have 2 apples minus 3 apples is equal to 5, and it just doesn't make sense you have negative apples, right? Because it doesn't make sense because you have 2 apple, take away 3 apple, you don't have enough apple to take away. So that becomes the first obstacle. So the first obstacle start with the real number and then go to the negative numbers. Negative number in this case is going to be negative apples is equal to 5. And for them, negative apple doesn't make sense. Or apple is equal to negative 5, it doesn't make sense. But when it start making sense is when they start talking about debt. Like if I owe somebody, like if I owe you $5, then it's negative 5 for us between me and you. Well, you have I have plus. If I owe you $5, so that means you have plus 5. I have a negative 5. So there's a negative version. So, and Chinese people don't believe in debts. So they don't want to believe in negative numbers. Well, America does. Yes, we have a lot of debts. So it's all a negative number. Now later on they say, well, so this is a real number. This is a negative number. So it start having negative number. The negative number kind of evolved. Now, what is rational number? Do you guys know what's rational number?
A correct number.
What is a rational number?
3.
No. Well, 3 could be irrational, but what is the definition of rational number? No. But whole number could be a rational number, though. What is a rational number?
A number that can be something by itself, right?
No.
Okay.
Nobody know what's a rational number? What? What is that? Can you elaborate more? You're almost there. You're almost there.
Like the definite number. Right, like
Rational number. No one can tell me what rational number is? Yes, Chase.
like a number that doesn't repeat.
You are saying the same thing as Shreya.
Joe.
So rational number. What's a rational number? Somebody raise their hand over there. Luke, do you know what's a rational number?
I would say like a rational number,
Can you give me an example of rational number? How about that?
like 2.
Well, 2 could be a rational number, but it's not exactly definition of rational number.
I mean, I would say it's something that doesn't have a repeating decimal, but that's what they both say. So.
Repeating decimal, but they did not say. They did not say. They said repeating, but you say repeating decimal. Repeating decimal is good, but what's causing repeating decimals?
If like something can't be divided into another,
You're almost there. It's actually something that's in fraction. So rational number. So I'll start with a rational number. Is equal to a fractions. So anything can be put in fraction. Even whole number can put in fraction. 2/1. So whole number is rational number, but not all rational number are whole number. Does that make sense? So for example, 2/3. That's rational number. And that's repeating decimals because that's 0.66666, right? And that's repeating decimal. So this is called rational number. Anything can be put in fraction is called rational number. So then you can say 1 apple is 2/3 pound. That's fine. Now I'm going to talk about a lot of things like this too, and that's you understanding the basic foundation of numbers. The basic foundation of number is, so you start with a whole number, and you start with a negative number. So the apple is equal to -5. So this is a negative number. And then you start with the irrational number. Rational number is 2/3, right? And so sometimes they say, well, here's a question. Is a 2/3 better answer, or is a 1/3 better answer, or 0.3 repeating better answer? So I'm going to ask you, is a 1/3 is a better answer, or 0.6 repeating a better answer? Oh, sorry, 0.3. Why is 1/3 better answer? Well, that doesn't explain why it's better though.
Easier to multiply.
It's easier to multiply. That's actually good. Think about it. If you have 1/3 and 1/3 and 0.3 repeating, 0.3 repeating. If I add together, this side is 1, right? And this side is 0.9 repeating. So 0.9 repeating is approximations, right? It's not really 1. It still have missing that one small pieces. But fractions better representation than repeating decimals. Is that okay?
Yeah.
So now we have rational numbers. So we start with, let's repeat, whole number. So that's going to be 1, 2, 3, 4, 0, 1, 2, 3, 4. And then you got a negative number. So it'll be -2, -1, -4. And you got a rational number. Then you got 3/7. That's rational number. Now, what's the next thing we're going to study? Irrational number. Now, it becomes really tricky. Do you guys know what irrational number is? Yes, Chase?
So like a repeating decimal, but not a repeating decimal, but like the
That's kind of contradicting.
decimal, but it keeps going on, but the numbers aren't the same.
I don't know if that's the right answer. Elizabeth?
Number that cannot be put into a fraction, like 5.
Okay. And you, Devin?
First question.
Improper fraction? No. Elizabeth was right. anything cannot be put in a fraction. So a rational number, it becomes pi. Do you guys will learn a value called e. You guys know what e is? E is called Euler's number. It's 2.718 something, and it's 3.14 for pi. So those that cannot be put in decimal. But I understand what Chase was saying.
What did I say?
Is there is no repeating decimals. I think that's what Chase was trying to say earlier. So it doesn't have repeating. So is it pi or e? E is an Euler's number. Now there's another one that's really weird. So for example, this one, x squared equal to 2. How do I solve for x? Square root both sides, so you're going to get plus minus square root 2. Square root 2 is not repeating decimals. So square root 2, square root 3, square root 5. But what about square root 4? Square root 4 is actually a whole number.
Yeah.
Right? And it can be rational, but it doesn't have to be. So a rational number is going to be square root 5, square root 3, square root 2, pi e.
Wait, so your answer for x squared is just x squared?
Square root of 2.
Just negative that.
Yeah, because square root 2 times square root 2 is equal to 2. Now it becomes a kind of tricky now. So what if you have a x squared is equal to negative 4? And then you're like,
Yes.
x equal to the square root of negative 4 is going to be like this, right? Plus minus. It's actually a plus minus, by the way. So x is equal to, well, here's the thing. How is it possible? Like, for example, right? You think about it. Square root of 9 is, think about two numbers multiply each other. It's going to give me 3. Right? So that is 3. So that square root of 9 is 3. But what is square root of negative 4? Which two numbers multiply each other?
2.
It's going to give me negative 4.
Negative plus minus negative. It's positive.
The same number was
So it's mind-blowing. Because you cannot think of two of the same number, multiply each other is going to give me negative 4. So mathematicians kind of think about it as slightly different. Mathematicians think about in geometric understanding, but later I'm going to talk about that. There's no way that you can multiply two numbers. It's going to give me negative 4. Two of the same number. Two of the same number. So mathematicians come up with this so-called imaginary number. Imaginary number is, we're going to talk about that in a little bit. It will start making sense. But we can say that square root of negative 1, we're going to call it I. And this I, and everybody is like, wait, I doesn't make sense. There's no way that makes sense. But it does. But it happened later though. So this becomes the biggest problem for a long time, for like 100 or 200 years. There was two numbers multiplied together. Does not give me negative 4. There's no way that you can find those two numbers.
Or central.
So what happened is we will come up with a solution is this. We can say square root of negative 1 times square root of 4. And this becomes I. So that becomes plus minus 2I. And you're like, I doesn't make sense. Okay. And then, yeah, it doesn't make sense for now. That's okay. We're going to start it and introduce you I. So today you are learning this. This is the first rule imaginary number. Square root of negative 1 is I. Now, what is I squared? -1. And that's the second rule. So let's start deal with let's start deal with i's. Let's say if you have 3i minus 2 minus 2i plus 1, like this. Can you simplify this? Last year you done this, right? In Miss Davies' class or in other people's Algebra 2 class, you should have done this. Don't treat I any different. Think about it as x. You can say 3i minus 2 minus 2i minus 1. And that's going to be I minus 3. Better yet, you should write it this way, -3 plus I. And there's a reason for that. You should write all your solution in the integer first and then complex number second. It's called A plus BI form. A plus BI form. A is real. So this is called a real part. And this is an imaginary part. And trust me, I'm going to come back to answer that I situation. So A plus BI form. It has to be right in an A plus BI form. I didn't do anything different. I just treated it like X. I just simplify. I distributed combined like term. I got it. Any questions so far? Yes.
So like the whole by is imaginary part?
Yeah, no, this
Only the one.
is a B is the imaginary part. The I just that just dictates says that's imaginary parts. But the B is the for the imaginary number. So A plus BI form. Now later we're gonna start to develop more. We say, can we multiply in complex number? So what if I have 2i minus 1 times 3i minus plus 2? So now we're not adding and subtracting anymore. We are going to multiply. When we multiply by the complex number, this is going to be multiplied together. Is that okay? It's going to be 6i squared. And if I multiply this, it's going to be what? Plus 4i. And if I multiply, let's say it's this, what am I going to get? -3i and minus 2. Can I combine like term? So it'll be 6i squared plus i minus 2. Now on the things, you have to recognize what the I squared is. What is I squared? -1. So it's going to be 6 times -1 plus I minus 2. And that's equal to -8 plus I.
Oh.
Now, on my test, I'm going to ask you to graph what is -8 plus I. Okay, so I'm going to ask you to graph it. Now, this one is called real axis. Real axis. And this is an imaginary axis. So this one's going to be I, this one's going to be 2i, this one's going to be 3i, this one's going to be 4i. Is that okay? And then this one is going to be 1, this one's going to be 2, this one's 3, this one's 4. So it's going to be -1, -2, -3, -4, all the way to -8. So this point here represents -8 plus I. That particular point, this point is called -8 plus I because you go to the real part first, which is -8, and you go up because of plus I. So it's kind of like the coordinate. is negative 8i. Is that okay? Am I going too fast?
A little bit.
So how would you increase the R?
Let's just say if it's negative 8 plus 2i, then it's going to be this point right here because it's going to be plus 2i. It could be minus 2i or be on the other side. So this one will be, sorry. So this one's negative 8 plus I. Don't worry about this point. Sorry. Oh my goodness. Okay. Don't worry about the point. If you want a 2i, it's going to go up one more. Is that okay? So I'm going to ask you to graph this. But I want you to simplify first. 5 plus 2i times 4, 3i minus 2. Okay, I want you to multiply this and graph it. Multiply this and graph it. So not only in this, you multiply and you graph it. Now, I'm going to teach you something that you never learned in Algebra 2 in a second, but, sorry. But don't make simple mistake. Again, simple mistake like this, just to be very precise on your calculation, learn to be like very calm when you're doing the calculation. Don't make sign errors. When you replace something, always put a parenthesis, especially I squared, change it to that -1, and you can check with each other, see what they get. So 5 plus 2i times 3i minus 2. But write in a plus bi form. A plus bi form is very important that you gotta be able to do.
Yeah, I guess.
Can somebody tell me the question again?
5 plus 2i.
5 plus 2i,
3i minus 2.
3i minus 2. Do you guys multiply out? Do you guys check each other answers? Okay, if I multiply this, what am I gonna get? 15i minus 10 plus 6i squared minus 4i. Now only an I squared need to change to -1. The other one doesn't need it. 15i minus 10 plus 6 times -1 minus 4i. Now I will get 11i, right? 15i minus 4i. And this one's going to be what? -16 plus 11i. So I'm going to graph it. I'm going to graph it. So the real number is going to go to -16. Is that okay? And 11i is going to be right here. So this point is called -16 plus 11i. That point. Okay, so that point is called -16 plus 11i. Am I going too fast? Okay. Now, something you never learned in Algebra 2. That is in, like a math competition, the Algebra 2 competition, they will show up. But not in the Algebra 2 itself. We're going to learn about magnitude. Okay. Which is, looks like this. Absolute value. Now that's something you never learned in algebra 2. Absolute value of negative 16 plus 11i. Do you know why absolute value is invented?
Make it positive.
Good. But why do you want to make it positive?
Because you don't.
Yes, why?
They're yes.
They
They're
are.
not real.
No? Yes, look.
Well, in some cases, like negative numbers don't make sense, like with speed or whatever.
I like that.
You can't have negative.
Okay, so absolute value is invented in math is due to speed. That's one reason. Because speed cannot be negative. Speed is only positive. Velocity can be negative. Very good job. But the second thing is actually distance. So let's just say me and Arthur, right? So I'm going to write down here that this is the 0, and this is Arthur at positive 2, and this is a Mr. Ye at negative 3. And so the distance between Arthur and Mr. Ye is what? 5. But Arthur says, I like this calculation. 2 minus negative 3, that's equal to 5. But Mr. Ye says, no, I don't like that. I like me go first. So I can say negative 3 minus 2. I do my position, subtract his position. But then I get negative 5. What's one way to get around it? We put an absolute value around both. It doesn't matter who's at the beginning. So therefore, this one becomes 5. Because absolute value of negative 3 minus 2 is going to be absolute value of negative 5. Absolute value of negative 5 is positive 5. So it doesn't matter if I go first or Arthur go first. We can subtract each other, and then we just put an absolute value around it. So it turns out that this is talking about distance. But distance compared to what? Distance to where?
0.
Yes. Who said 0?
Sure.
Good. How do I find the distance from here to here? How do you find the distance from here to here? You can count, but besides that, using basic geometry.
I was kind of trying to solve problem.
So this distance 16, right?
Yeah.
And this is distance 11. Can I use a Pythagorean identity?
Yes. 8.
Okay, so it's going to be 11 square plus 16 square, and then square root of that. So that's equal to square root of 121 plus 256. So it'll be square root of 371. So this is equal to the square root of 371. It's the distance from origin to that particular point. You never learned that in Algebra 2 because it's not in Algebra 2 curriculum. But absolute value of the thing is the distance from that coordinate to the zeros. 0, 0, to the origin. And the best way is not including the I, just take account into the distance. This distance is 16, and this distance is 11, and just take that as 11 and 16. Don't worry about negative sign. Yeah, they just distance. So square root of 11 square plus 16 square is 371. So today I will ask you that as well. Now, lastly, I'm going to answer that question. Why is I? Yes.
So you'll give us an absolute value and we have to do the square root thing?
Yeah, square root of a 16 square and an 11 square. And you have to figure out, but if it's something you can take it out, you can take it out. So it's actually give you a defined number, square root of 371. So this is equal to square root of 371. I know I'm going a lot of material, but a lot of material are fairly easy. It's something you've done in Algebra 2. This is the only part you did not done in Algebra 2. but this is the only part that you can probably do in geometry. That's absolute value of something.
This is like middle.
Supposedly. But middle school teacher is not gonna go that deep. Okay, let's answer that I. How does I work? Now, I is gonna be very impressive, like once you figure out. So first of all, do you know what's I to the 243 power? Have you guys done this before in the past?
Yes, it equals the same thing as the thing. You know, 4 different eyes. There's 4 eyes. They all equal different things. That one's equal. I couldn't tell you.
I'm gonna explain that in a second. Okay. So for number, you think about a number multiply a number, right? So that's a 2 times 3. That look at the number line is 1, 2, right? Times 3, right? Sorry. Let's go back. Times 3. So 2 times 3 is equal to what? The result is going to be what? 6. Yeah, you guys know how to do math. So this is 6 unit. This is 2, this is 3, right? 2 times 3. Now what happened is 2 times negative 3? Yes. But, okay, so let's do a second situation. So you have 0, this is a 1, this is 2. I'm going to go with 2, and I'm going to times by negative 3. Negative 3, so I'm going to times this each other. I'm going to use different colors so that way you can see. And the result is what? Negative 6, right? But do you see the result change 180 degrees? It changed 180 degrees to going the other way. Now remember, the I squared becomes negative 1. Now, what does I squared do? Remember, this is going to open up your eye a little bit. Remember that imaginary number, this is 1, this is I, this is negative 1, this is I, this is negative I, right? If you, that means 2 of the number multiply each other, it's going to give you a negative number. That means you're not doing a 180-degree rotation. You're doing a 90-degree rotations. Okay, so I know some of you guys are lost, but believe me, you can do this. So remember, 2 times 3 is equal to, not changing. 2 times 3 is going to go with a positive, right? 2 times negative 3 is going to go the other way because it's a 180-degree flip, right? So what happens if you have 1 times I? What's a 1 times I? I, right? So 1 times I is I. It's a 90-degree rotation. And what happens if you I times again? I times I. Another 90-degree rotation. So it's rotating 90 degrees. It's totally different perspective in math now. It's like before, so now we have a way to get to the other side, but multiply itself. So for example, like says 2i times 2i. What is 2i times 2i?
Negative 4.
Negative 4. Why is negative 4? Because we start at 2i, right? And multiply by 2i. So if we start with 1 times 2i, it's going to go here. And times 2i is going to go here. So it's going to go to negative 4. So it has a 90-degree rotations. It's like, no? Kind of? Okay. So that's answer I 243 degrees. Some people says I to 240 degree. I remember my teacher says this. I to the first degree is I to the second degree is negative 1. I to the third degree is I squared times 1. So what's I squared? negative I, right? So what's I to the fourth? I squared times I squared, so it's -1 times -1 is equal to 1, right? And my teacher told me, says I to the fifth power is I to the fourth times I, which is 1 times I, which is I to the sixth power is equal to I to the 4 times I squared, which is equal to -1. But you see they repeating. I'm going to do it again. I to the seventh power is I to the fourth times I to the third is equal to I to the third, which is -I. So -I. So -I. I to the eighth power is equal to I to the fourth times I to the fourth is equal to 1. So do you see that repeating? Sorry, do you see this repeating? Do you see this repeating? Do you see this repeating? It repeat every 4 times. So what are you supposed to do with 243? You divide it by 4. If you divide it by 4, this is going to give you 6. So 24 and left with 3, right? So that means you have a 60
-1.
rotation. And then you go to the third one, so it's going to be I to the 243 is equal to -I. Hold on, let me finish.
You are now dismissed.
This means 1, this means I, this is -1, this is equal to what? Is -I, right? So remember, if you have 243, that means you're going to go 1, 90 degree, 2, 90 degree, 3, 90 degree, 4, 90 degree. And that's why it shows like a repeating. So repeating for 60 times, remember, it's going to go every time, it's going to go 90 degree, 90 degree, 90 degree, 90 degree. So it's going to do it for 60 times. And after 60 times, you're going to do 3 more rotations. So it's going to be 1, 2, 3, -1. And this one should be -1, right? This one's, oh, this one's -I, sorry. This is -I. So it's -I here. So you see that rotation. That means every time you have imaginary number, you multiply by imaginary number, it's a 90-degree rotation. Okay, I'll see you tomorrow.
I see.
关学。